So this is our question. Now, one standard way is to notice that there's some kind of input difference, whatever it is to measure a difference, right? And then you measure language acquisition outcomes, right? So there's some sort of knowledge attained on the basis of that input, but the thing you're measuring is actually some kind of observable outcome, right? And then you see if the input difference correlates with any of the outcome differences that you measure. And if so, then the input difference might cause the outcome difference. Remember, this is correlation, so it might cause it. And so if so, then that input difference would be developmentally meaningful in this particular way with whatever outcome difference it's correlated with, right? So a new complementary way that I want to talk about uses developmental computational modeling. And so a developmental computational model is going to implement a specific learning theory, and in particular, a learning theory about how children use their input to do what? To acquire the knowledge that they use to generate their output, right? It tells you how you get from the input to the output, right? It's a causal story in this way, right? And in particular, something that's quite nice is that the learning theory implemented by the model specifies what aspect of the input matters, right? So you're not just looking at the input entirely, you're focusing on some aspect of the input. And the learning theory implemented by the model tells you exactly what part that is, right? So if we know what input part matters, we can target that part for intervention if needed, right? You know exactly what thing needs to be quote unquote fixed, right? So a developmental computational model is going to then predict the language outcome on the basis of that aspect of the input, right? If the predicted outcomes differ, then it's because the input difference caused that outcome difference. So the input difference is predicted to be developmentally meaningful. So these outcome predictions, of course, need to be verified with the predictions, but at least it's telling you what specific outcome you ought to be measuring, right, to see if that input difference is developmentally meaningful. Now the bonus, and this is something I mentioned before, is because the learning theory in the model is causal, it tells you how the input causes that knowledge to develop, which then the child uses to generate the output. Because that learning theory is causal, we can predict if the input should cause similar outcomes, that is, no outcome difference. In that case, the input difference isn't developmentally meaningful, right? So this is the goal then, to detect developmentally meaningful input differences. And of course, again, we have the standard way, which is measuring input differences, measuring outcome differences, and looking for correlations. And a new complementary way using developmental computational modeling is going to have a predictive story about how that input causes that outcome to develop, right? So I'm going to focus on that way today, as you might imagine, because it's me. And so the case study that I'm going to use to sort of demonstrate this approach is syntactic island acquisition. And you might say, okay, why? Well, one reason anyway is that it's higher order syntactic knowledge, that is more complex syntactic knowledge, where we don't actually know much. We know some, but not really a lot, about developmentally meaningful input differences across SES, across socioeconomic status. So it seems like a good place to start looking with this new complementary technique.